Hello, and welcome to another video of the TNOT 5G project. My colleague Elias Nectario and I, David Urquiza, will present you the 3GPP evolution toward 5G new radio. We will start by showing you the general structure of the 3GPP and the evolution of 3GPP towards the 5G new radio specification. Then we will make a comparison between LTE and 5G, highlighting the main features introduced in 5G. The third generation partnership project is composed of 7 telecommunication standard development organizations from all over the world called organization partners. The main goal of 3GPP is to provide the technical specification and reports for the cellular communications. However, 3GPP has been involved in the development of a specification for the core network as well as for non-cellular communications. 3GPP is divided in 3 main groups: the radio access network group, the service and system aspect group, and the core network and terminals group. The radio access network group is responsible for the definition of the functions, requirements, and interfaces of the network, with focus on the time and frequency divisions. The service and system aspect group focuses on the overall architecture and service capabilities of the system. This group is responsible for the cross-group coordination. Finally, the core network and terminals groups focuses on the specification of the logical and physical terminal interfaces. This slide shows the most important milestone of 3GPP over the years. 3GPP had as initial goal to provide a technical specification and reports for the third generation mobile networks back on 2000 for both the radio access and the core. On 2007, 3GPP introduced the high-speed packet access evolution with focus on the improved quality of service terms and decreased latency for real-time application. On 2008, the first release of LTE was introduced with FDMA and MIMO being the most important new characteristics of the new radio interface. On 2011, the last and final version of LTE was introduced entitled as LTE Advanced. On 2018 and 2020, we had the first and second phase respectively of the 5G New Radio. 5G New Radio introduced several novelties on the telecommunications society. 5G New Radio defines 3 main services types, named enhanced mobile broadband communication, ultra-reliable and low-latency communication, and massive machine time communication. It is foreseen that in 2023, the 5G enhancement will be introduced with focus on machine learning, energy efficiency, and other features. The 5G new radio functions and requirements are described in the 38 series of the 3GPP. This specification defines how both the control and data information is exchanged between the various network nodes at the radio access network level. In this slide, we can see some difference between 5G new radio and LTE in the physical layer. In 5G new radio, we have a mapping between subcarrier spacing and maximum bandwidth per component carrier compared to the 20 MHz of LTE. In addition, the number of carrier components increased from 5 to 16. In 5G new radio, we have a variable number of carrier spacing with multi-numerology being an advantage of the 5G. Moreover, for bandwidth compatibility, we have the same subframe length while the latency is reduced. In addition, 5G new radio supports a better and more efficient utilization of massive MIMO antenna arrays, including multi-user MIMO. In order to guarantee a high-order MIMO system, new channel state information acquisition techniques are developed. 5G new radio supports 2 types of channel access information feedback. Type 1 is used for single-user MIMO transmissions. The codebuds for Type 1 are relatively simple and used to focus the transmit energy at the target receiver. This type of acquisition has lower signal overhead. A precoding matrix information report may consist of a few tens of bits. On the contrary, Type 2 mainly targets multi-user MIMO scenario with multiple devices being scheduled simultaneously with the same time and frequency resources, but with only a limited number of spatial layers per scheduled device. The codebus for Type 2 are significantly more extensive than Type 1, allowing the precoding matrix information to provide channel information with much higher spatial granularity. The more extensive channel information allows the network to select a downlink precoder that not only focuses the transmitted energy at the target device, but also limits the interference to other devices simultaneously scheduled on the same time and frequency resources. As a consequence, Type 2 demands higher signal overhead, and is mainly applicable for low mobility scenarios where the feedback periodicity in time can be reduced. In summary, 5G New Radio introduced several new features. At the frame structure level, 5G supports scalable numerology, the introduction of the mini slot and a front-load demodulation reference signal guarantees low latency and reliable communications. The use of millimeter wave allows a wideband transmission, and techniques such as beam sweeping, bit management, and massive MIMO systems have been proposed. To conclude, specifications are of paramount importance for network engineers as they provide a common way of interacting among systems from different vendors. Today we saw an overview of the 3GPP specification focusing on the novelties of the 5G New Radio. Over the years, 3GPP introduced several generations of the mobile communication networks, starting from the third generation and reaching up to this moment, the fifth generation, with many more to be foreseen. The fifth generation was the first one to consider something more than the radio access network and went further to the services. The future will show if the incoming generation of 3GPP will stick to the radio access network or further improve the services provided. Thank you very much for your attention.